Good morning, everybody. Within short time, we are starting the program, and I welcome you all for this an international program. Though the situation is dense outside, but last year IEEE USA granted us $500 to $750. So using that, we are able to perform with great difficulty. Today morning, we are gathering here. Though the experts from IIT Delhi and RCI, they want to come physically today due to some emergency and COVID in Delhi once again expanding exponentially. That is the reason behind they are joining online at 10:30 a.m. today. And tomorrow physical meet, everybody is coming. So tomorrow sharp 10 o'clock we are starting. One is gallium arsenide enabling technology, how it is useful to RF and microwave engineering, latest trends in technology. Dr. M. Sandeep Chaturvedi, Deputy Director, gallium arsenide enabling technology, who is addressing you people tomorrow morning 10 to 11 a.m. 10 minutes break tomorrow after his lecture, electromagnetic theory and compatibility. You are second years studying next semester. Anyway, they are showing you what are the implications of EMI, EMC interference to antenna. All these things, the experts are coming physically and interact with you. And one more good news to IEEE, Matrisri, MTT, APS Society is the headquarters granted $500 more for organizing one more program free of cost for you people, because you people joined voluntarily in IEEE. And one more industry visit also free of cost. The local MTT-Society chairman has agreed in principle. Tomorrow he will be addressing you people and announcing that if situation is positive and government permits us physically to meet gallium arsenide technology complex at Balapur, we are arranging 2 buses for you to visit how a VLSI integrated circuit is designed physically in the factory, in the industry. That is also arranged for your benefit, because you people all are VLSI studying, digital system studying, everything. So these all are the already roadmap designed by IEEE volunteers, faculty side. So we are requesting you, after attending all these things, you should encourage your colleagues. So if you join, of course, you people may think I paid a couple of thousands, what benefit I will get? Overnight, nobody will get any benefit. And remember, this effort which will come into limelight in your life after finishing or completing your graduation here. If luck favors, before final year itself, you can grab the opportunity from IEEE. But you have to navigate from your side. That is the input. Nobody will give you all the way the pushing or propulsion to move forward. You have to come forward, and you have to motivate yourself, and you should drive, and you should act as a driving force for a train of like this, and you have to add more compartments. What I mean to say is, you have to educate your own colleagues. These all are the benefits. Like that, membership mela, etc., etc. And one more thing, July, August, international level conference come workshop, IEEE Hyderabad section is planning in collaboration with local leaders, student network leaders. You can join their hands. That is my sincere advice. And one more thing, I was selected in MGA level USA, my name was recommended from India to control the membership strength and enhance. Not only, but also quality-oriented programs. We made a recommendation to MTT, antenna, and digital system design also, VLSI and other areas. So it nomination already received individually and it is recommended. So across the globe, my name is recommended from R10 as well as Asia Pacific region to conduct more number of events internationally. So you will get benefits not over time, overnight. So that is my sincere input, and you have to spend some time apart from regular studies. And online, so many webinars they are arranging, you have to join. And so many RF workshops free of cost IEEE is doing. Hence, we are requesting you to educate yourself not only, but also you have to encourage your colleagues. Maybe second year, maybe first year, it is immaterial. But don't think that this subject was not covered and we are unable to. And how many here second year CCE? Recently, the college has encouraged you people by conducting a value-added course, Python. Certificates came, we will distribute, don't worry, online digital certificate. You have to download and frame it. That is your responsibility. And college spent, EC department, 1 lakh rupees for that. And you people learned something and you yourself educated yourself, though you are exposed a little bit in C++ or C language. But the way in which the industry experts explained, you know, already you energized. So you have to continue with that, don't leave it. So then it will be useful for your paper presentation, not only, but also for your industry project, internship, everything IEEE is providing. And one more thing, IIIT Gachibowli is offering for IEEE student members free of cost internship program. If you successfully completed that internship program within the span of 65 days to 120 days maximum, whatever payment you have been done, it will be given back. 2,000 rupees registration fee, suppose. If you completed within short time and submitted the project work related to internship, online only, you need not go anywhere in this world, sitting at home and do. You will get, and it will be in Python, Java, etc., latest trends in Tekla, AI, ML. In that, IIIT Gachibowli is organizing. So you are an IEEE member, that is the reason behind instead of 6,000, they are charging as a deposit only, 2,000 rupees for IEEE student member. If you complete within 180 days to 120 days or 65 days, I do not correctly, you will get back those 2,000 credit into your account as an incentive. One student got, I think present final year student got it from our college. So these all are some incentives you have to grab. And one more thing, 24 hours IEEE extreme program is there, in which Python language you can show, you can choose, and whatever questions they are posing online, you have to answer. 24 hours program. If you grab it at least second position, we aim at here, we can jump there. We cannot jump to 42,000 kilometers satellite orbit. Let us assume first jump and touch there. That is second position. 55,000 rupees they will give IEEE. First position 1 lakh and 1 Singapore ticket free, air ticket. So these all are not, I am telling, it is there in the website, please go through. And I welcome you all once again for this 2-day workshop on microwave antenna measurements and simulation studies using HFSS. And today the 10:30 to 11:30, Dr. S.K. Kaul, Emeritus Professor of IIT Delhi and Asia Pacific region, IEEE MTT-Society Regional Director. And he is the motivating force to run this show. And MTT-Society headquarters donated us some 2 lakhs worth antenna. Those things we are useful to you for your project for measurements. All these things today and tomorrow, the experts are coming from industry in the afternoon session. Physically, you can do the simulation studies also, antenna design. So this is a level 1 course. Don't think that they have done only one antenna, I paid 100 rupees, don't think like that. So it is a continuous process. Then only you can master in HFSS, high frequency simulation software. So evening, afternoon session, after lunch 1:30 to 4:30, Rajasri Rani madam is coming, though she is suffering from fever. Because of this IEEE program, everybody should follow the protocol. So that is this input, and tomorrow one industry design antenna they will give you in the afternoon session. Morning session, electromagnetic compatibility interference as well as gallium arsenide enabling technology, materials useful in antenna design, metamaterial, etc., etc. So these all are the inputs, though we have in short time 4 guest lectures followed by simulation studies. Nothing but it is a IEEE level, minimum 6 hours in a day we have to work. That is why 10 to 5 we are working today as well as tomorrow. So these all are the issues. And one more thing I am promising you, next time, maybe before December 2021, if everything allows us in a positive mode or positive way, then we are inviting one eminent speaker from Singapore to this college in terms of terahertz technology. That is the latest trends in technology, 5G. Today, first lecture is millimeter wave and 5G, extension of that 5G antennas and antenna applications, and the next one is communication module. So these all are DLRL experts are coming online and explaining you people in terms of applications of antennas and metamaterial latest trends in technology. Now I invite okay. Done.
Hello. A very good morning, everyone. Respected principal, beloved teachers, and my dear friends. A hearty welcome to you all to the 2-day workshop on microwave antenna measurements and simulation studies using HFSS, which is starting today, that is 26 February 2021. This program provides an exposure to new area in antennas and microwave field and enhances the capability competence by providing exposure to practical problems and solutions through case studies and live projects. Now, I invite our respected principal to please come on to the stage. And now I invite our HOD of ECE department, Dr. N. Srinivas Rao sir, to please come on to the stage. Now I invite IEEE student branch counselor, Mr. D. Nagaraju sir, to please come on to the stage. Now I invite our coordinator, Mr. M. Naresh sir, to please come on to the stage. It is always a tradition to start any event with a prayer. Now we shall start our inauguration program with an invocation song by Aishwarya.
महागणपतिं मनसा स्मरामि महागणपतिं मनसा स्मरामि महागणपतिं मनसा स्मरामि महागणपतिं गणपतिं मनसा स्मरामि वसिष्ठवामदेवादिवन्दितमहागणपतिं महादेवसुतं गुरुगुहानुतं महादेवसुतं गुरुगुहानुतं मारकोटि प्रकाशं शान्तं मारकोटि प्रकाशं शान्तं महाकाव्यनाटकादिप्रियम् महाकाव्यनाटकादिप्रियं मूषिकवाहनमोदकाप्रियं महाकाव्यनाटकादिप्रियं मूषिकवाहनमोदकाप्रियं महागणपतिं मनसा स्मरामि महागणपतिं मनसा स्मरामि वसिष्ठवामदेवादिवन्दितमहागणपतिम् Thank you.
Thank you, Aishwarya. Now, I request our HOD, Dr. N. Nukala Srinivas Rao, sir, to please address the workshop.
Good morning, respected Dr. D. Hanumantarao garu, Principal, Coordinator Naresh, and Branch Counselor D. Nagaraj garu, my dear colleagues and student participants, invitees, both online, offline, who all are watching MTT family. I welcome you all for this 2-day blended mode workshop on MTT Microwave Theory Techniques Society sponsored and IEEE Hyderabad section support technically collaborative and IEEE student branch Mathrusri Engineering College MTT student chapter and IEEE student branch Mathrusri. So we are welcoming you, and total 40 students have been strength of this Mathrusri Engineering College IEEE student branch, in which 30 plus are Microwave Theory Society membership, which was sponsored by Mathrusri Engineering College for as an encouragement, because you have shown some interest. That is why college has sponsored by paying 30,000 rupees as the additional incentive for you. Now you have to keep it in a alive mode. So the day 1 program is focused on 5G technology communications, latest trends in technology. That is nothing but terahertz technology application. And one more thing is antenna applications in RF, second lecture. First lecture is Dr. S.K. Kaul garu from IIT Delhi. He is sorry, is busy with some other work, joining online and educating you all the benefits as well as the latest trends in 5G communication in antennas and other avenues also, opportunities. And second lecture will be Dr. M. Lakshmi Narayana garu, educating you in terms of antenna applications once again. Afternoon session 1:30 to 4:30, HFSS physical simulation. Madam Rajasri madam is coming from industry. She is arrived. Now she made a call also. She is educating you people. Last week we have conducted same thing, step by step. Madam will explain how to design an antenna physically using a computer, using HFSS software. Tomorrow's program is Dr. Sandeep Chaturvedi, MTT-Society Hyderabad section, Chairman MTT-S. Sir is explaining you people in terms of gallium arsenide enabling technology using metamaterial technology in an antenna design for biomedical signal processing, not only but also for SATCOM, satellite communication. And one more thing, followed by previous chapter chair Sandeep. He is coming physically and explaining electromagnetic theory and electromagnetic compatibility. All are related to EC curriculum only, but IEEE standards we are able to organize to motivate you people. Afternoon session, once again, industry-oriented application using HFSS software, we are organizing practical session. So these all are the a basic level course for you, And IIT Delhi is organizing mentorship programming and internship programming. If you qualified in that with 65% entrance test marks, you will be giving 44,000 rupees. One of our Nagaraj garu knows that. He will explain in that. So please grab the opportunities wherever, whenever IEEE is announcing. Thank you one and all for giving me this opportunity. Good luck. Thank you.
Thank you, sir. Now I request our respected principal, Dr. D. Hanmant Rao, sir, to please address the workshop.
So good morning, one and all. So after a long time, nearly close to 1 year, so students sitting in a seminar hall and attending. Thanks to all the students who physically present over here and those who are watching YouTube streaming. Because you know how the classwork is going on. Half of them, they are only switching on the video and mic, and when we call attendance, then after 15 minutes, student will turn up. Okay. So hopefully from now onwards, we'll have some constructive learning. And just now, HOD is saying that, and the schedule also shows 2 half-day sessions of HFSS physical practice, the software. Okay. So this recently we procured for the benefit of all the students. And I thank Professor Kaul, sir. Actually, he's supposed to be here because of preoccupied assignments, he couldn't come. So earlier twice he visited our college, and as far as my knowledge is concerned, they already donated a few antennas around 2 years back. We are luckily one of the institution. Only 3 colleges they supported in that sponsorship program. And from last 3-4 years, repeatedly, Professor Kaul sir is saying that his institute is, that is IIT Delhi, is open for internships or for any other research activities in this field. But no one is taking it to the final level. Hopefully after this workshop, and I think today nearly 1.5 hours or 2 hours, sir is going to interact with you. So at that time, once again, you please verify what are the modalities. I request our faculty also to apprise you once again. I think only for one batch, Mr. Abhay Joshi went all the way to Delhi, spent there for 45 days. Nagaraju sir also. So he physically was there. So use these kind of an opportunities. Okay. Because we have a very big internationally renowned professor is trying to help us. But due to obvious reasons, the students are not turning up to the final stage. So hopefully at least in the next 6 months or 1 year. So some of you sitting over here are sorry, watching online. So any support in this regard from the college definitely will also extend the necessary help. Okay. So we want to create some kind of a facility. Even HOD is also interacting with the DRDL people on few of the antenna designs, some expecting some kind of a consultancy in this area. So all these things are only to upgrade your knowledge levels in this specific area. And I hope these 2-day deliberations will increase your knowledge level and utilize the facility and come out with some innovative products and all those things. Thank you and good luck. All the best.
Thank you, sir. With this, we conclude our inauguration program. Please take a few minutes of break and then we'll continue with the first day of workshop. Thank you.
Yeah, it is okay. It is there now. Okay. So I'm there whenever you want me to start, I can do that. Huh? You just ask him, huh? Because then I have to do sharing. Huh? No problem. So whenever you want me, just tell me. Then I will upload the slides. Huh? Okay. No problem. No problem. Yeah, sure. So, and when you want me to start, and don't put too much of introduction, I don't want to waste time. It's better we can start with the thing. Eh? So, I should I share the slides right away, or yeah, yeah, but I will. No, no. What I'm trying to say, I can just share it and leave it. I won't start it. Is it okay, or I? I'll do that. Okay, 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 okay.
आपको दे दूं जूस ग्रीन जूस के नहीं
ये रही तो और कप चाय देखते बस
अभी मैं चाय ले रही हूँ चाय तो दे दूं इसलिए आपको
Yes, sir. Welcome back, everyone. Now we are about to start with our first day of workshop. It gives me immense pleasure to introduce to you all our first guest speaker, Dr. S.K. Kaul. Professor Kaul is a fellow of the Indian National Academy. Professor Kaul is a fellow of Indian National Academy of Engineering, India, and Institute of Electronics and Telecommunication Engineers, IEEE, India. He is the chief editor of IEEE journals. He is the chief editor of IEEE Journal of Research and associate editor of the International Journal of Microwave and Wireless Technologies, Cambridge University Press. Professor Kaul received the BE degree in Electrical Engineering from Regional Engineering College, Srinagar, India in 1977, and the MTech and PhD degrees in Microwave Engineering from the Indian Institute of Technology, that is IIT Delhi, in 1979 and 1983 respectively. He is an emeritus professor with the Indian Institute of Technology, Delhi since 2019 and mentor deputy director with IIT Jammu since 2018. His research interests include high-frequency wireless communication, microwave engineering, microwave passive and active circuits, device modeling, millimeter wave IC design, and reconfigurable microwave circuits, including antennas. He has successfully completed 38 major sponsored projects, 52 consultancy projects, and 61 technology development projects. He has authored and co-authored 490 research papers, 13 state-of-the-art books, 4 book chapters, and 2 e-books. He holds 16 patents, 6 copyrights, and 1 trademark. He has guided 25 PhD theses and more than 100 master's theses. He is the recipient of numerous awards, including IEEE MTT-Society, Distinguished Educator Award 2014.
Hey,
Teaching
Babli.
excellence.
Abhi?
He also received Teaching Excellence Award from IIT Delhi, Indian National Science Academy, Young Scientist Award, Top Invention Award of the National Research Development Council for his contributions, and many more.
Yeah, okay. Okay. I will actually start
Thank
the
you. We
sharing.
welcome
Huh?
you, sir, please.
Huh?
Is sharing, right?
Is it visible? Are you able to see the slides?
Yes, sir.
Are you able to see the slides or no? Just 1 minute, 1 minute.
Yes, sir. Yes, sir.
Just 1 minute. Stop presenting. I'll just do again. A window. Share. Is this okay now? Hello?
Okay, sir.
There's some problem with the sound. Are you able to hear me?
No, sir. No, you can continue, sir.
No. Are you able to hear me?
Yes, sir. We are clearly hearing.
Okay. So should we start it or what is the program?
You can start it, sir.
Okay.
Thank you, sir.
Okay. Good morning, ladies and gentlemen. Just 1 sec. Sorry, actually, I had to get up. So, in the next 45 minutes to 60 minutes, I'll be touching down upon the role of MTTS in shaping your career and low-cost internet development for 5G applications. So, if you have any questions at the end, okay. So, first of all, I would like to take this opportunity to thank Srinivasan, and he has been after me to give this inaugural talk. And also, we have now Sandeep has taken over as the section MTT chair, and I think I'm sure that in years to come, maybe this year and in future, the microwave activities in Hyderabad will jack up with a nice team of Sandeep and other section chairs. So briefly, I will discuss about what are the MTT roles and later have a technical application of 5G antenna designs. Now, if you know that there is convergence of RF, nobody talks of RF now, it is RF, microwave, millimeter waves, and now it is terahertz. So there has been tremendous growth in wireless communication, information communication technology, a lot of medical application, and continuous upgradation in RF technology and integrated circuits. And the general trend is to use higher frequency. If you know, 5G is 6 gigahertz, 28 gigahertz, 38 gigahertz, 60 gigahertz, and now 6G is going beyond 60 gigahertz. And we need to learn about planar transmission line architecture, silicon MEMS technology, CMOS, 3D, GAN, all those technologies are there. I think Hyderabad has excellent facilities, both in defense, GATEC, and other places. And then we need smart communication systems, 5G, cellular, radar, satellite, medical, student. So it's very, very important, you know, the education which we impart to the students, they have to be actually trained so that they can get better jobs in these futuristic areas. So this is very, very important. Now, these are the emerging 5G, 6G, cellular technology, disruptive technology, Internet of Things, fog computing, software-defined radios, low-cost millimeter wave systems, variable systems is extremely useful for healthcare. Then wireless high-definition radios, high data rate transceivers, security systems, air defense systems. So if we have students trained a little bit on these areas, I think they will have a much better future. So we started, way back in 1897 with Sir J.C. Bose. He demonstrated accidents of millimeter waves. Now we use it for 5G, made polarizers, semiconductor devices, dielectric lenses, and they are still at the Bose Institute in Calcutta. And some of his work was reported in the IEEE 1997. This is a very excellent idea paper on the contributions which he made. At IIT Delhi, we started the millimeter waves in 1979 when we conducted the first workshop. At that time, we didn't know that millimeter waves is going to be useful, so useful that today everybody talks of millimeter waves only. So these are the things which Sir J.C. Bose did: antenna, transmitting antenna, point contact detectors, polarizers made out of jute. He had a vision. And free space radiation receiver, variable attenuator, and there was no CST, HFSS at that time. But today we have excellent tools, so we can do wonderful things in India. But this is the problem. I have shown this at various forums, and this is the current state of micro education. At undergraduate is a basic course in electromagnetics, waveguide experiments, micro engineering. PG, there's micro theory and techniques, micro devices, antennas, and advanced experiments in antennas and waveguides. Because unfortunately concepts in UG are not clear, students don't want to take RF microwave courses after graduation. This is true, and many colleges don't even have these courses now. They are slowly going into AI, ML, all those things are okay. But I think if you want indigenous development, these are very, very important, especially with the boom in commercial applications of microwave millimeter waves. So it's very, very important. So the need of the day is keep abreast of RF to millimeter wave circuit design and technology. Is not desirable, is mandatory. In future, everything will be in millimeter wave area. Insufficient design education and hardware exposure is creating vacuum. We only teach students how to pass in the exam. We don't give them any hardware education. So there is a need for hardcore RF engineers who are equipped with design know-how. So like in this workshop, I'm glad that HFSS will be teaching you how to use HFSS for developing circuits. And also practical knowledge. You have to dirty your hands in the lab to translate these circuits into a practical reality. And keeping in view cost, reliability, and defense application, cost is not a problem. But if you look at commercial application, every dollar makes a difference. So this is not to be done in the industry. This is to be done in the engineering colleges itself. So we need to change totally the teaching methodology. We have to say electromagnetics is enjoyable. Don't use too many equations. I don't use even a single equation when I teach. And we have to show how the circuit elements behave at high frequency. We have to drive the student behind basic concepts to system level design. It's very important. When a student goes and works with Sandeep, he doesn't have any knowledge. So Sandeep would like to have a person who has some system level or circuit level experience. Then he can use him much better to develop the practical circuits. We introduced modern CAD tools, and I'm glad that you're conducting this workshop on HFSS, thanks to the HFSS team. And we have to also familiarize students with test procedures, introduce hands-on training by introducing relevant experiments in the curriculum. And this is the mantra. More practical oriented teaching, and in most institutions, and the emphasis is on completing the syllabus which is already outdated. Most of the colleges, we are interested in finishing of the syllabus which is already outdated. We're not interested in how much a student has learned. So we need to change total methodology of teaching electromagnetics. And then most of the people who are students, they're engineers, they don't know. We don't tell them what's your job. It's basically a professional practitioner of engineering. Apply scientific knowledge for technical and societal problems. We miss this. You have seen COVID. We wanted a lot of societal problems to be sorted, whether it is ventilator or it is X-ray to check whether COVID you have or no. And so if you look at the latent roots of engineer, it basically to devise. We are supposed to devise, not mug up and pass the exam. Do we do it? No. We have to clarify different concepts for other engineers and general public. We owe a lot to the general public. We don't actually do anything for the society. So the role and expertise of an engineer is as follows: develop new technological solutions, innovations to be given priority. And as some professors said, they are all in air. You have to simply catch these innovative ideas, but you have to change your mind that I'm not going to do mug up and pass the exam and get grades. I have to develop during these 4-5 years something which is cashy so that I can start a startup or I contribute to Atmanirbhar Bharat. Need of the day is carry out interdisciplinary research. Then we have to have highest ethics. We don't have ethics. We have obligation to public, society, employers, and we have to follow codes of ethics. College spends so much of money, like this HFSS workshop costs money. MTT-Society supports, and in Canada, they are given a ring called Engineer's Ring, which reminds you of your obligation. Of course, in India, we don't want to give you a ring, but please remember, when you spend 4 years at an engineering college, you have used a lot of taxpayers' money, so I have to give back to the society. That's something which you need to think about. Now, I will briefly tell you what's the role of IEEE MTTS, and as I said, we have already problem with the curriculum. It's an AICT curriculum and it's outdated. We don't revise it. So we ask students to follow the curriculum, complete the experiment. So how will a student get training so that his career is shaped for better things? So this is where the society, which is called IEEE Micro Theory and Technique Society, pitches in. So these are the things. First of all, to get these benefits, you have to be a member of IEEE MTTS. I'm sure Srinivasan made many of you, but I think Hyderabad, we can have thousands of members. Join MTTS. So you will have access to high quality webinars. I think every day there is a webinar, you have access to it about latest technologies. You have distinguished micro lecturers, speakers, speaker bureau programs. So you can make use of it depending on whether you want wireless power transfer, you want GAN devices, you want MMICs, there is a DML available. You have high quality journals for publishing research work. If you publish the research work, and it gives you promotions, it gives you satisfaction that you could do it. You can do patenting, which is called IP, and you can sell these products into some companies. Participation in world-class conferences, national and international. International Microwave Symposium is the best, but we brought a conference in India called IMARC, which is also international. You must participate in young professional and women in engineering. IEEE MTTS has taken special initiative to promote young professional and WIE activities. A lot of funding is available, and you will learn how to be a leader. We learned everything by joining MTTS. By joining as a volunteer, only give, don't take, but you will learn how we should become a leader. Then undergraduate, postgraduate scholarships are available with funding. In India, nobody applies. $1,000 for UG program or $1,500. PG program is $5,000. You have to submit a one-page application, and if it gets funded, then you have this fund for your research work. And then you have several chapters. They get funding for carry out activities, $1,000 plus $500. We join chapter $500. And chapter officers can avail funding for international travel and conferences to attend chapter chairperson's meeting. Right now, of course, it's all virtual, but from June onwards, you can physically attend and meet people. A lot of benefits. I can talk for full 1 hour on the benefits to the society chapters. Then these are the publications, your microwave magazine, then you have IEEE transaction. If you get a paper in IEEE transaction, it's like getting a gold medal. Microwave wireless technology letters, terahertz science technology, electromagnetic in biology and medicine. This is the very recent IEEE journal of microwaves. And then we're looking at transaction on radar systems, then multiphysics computational technique, on quantum engineering. It keeps on going basically from megahertz to terahertz technology. So it is from India, we publish very little because we don't train our students how to have high quality publications. Maybe we can give a separate talk later on this area. Then there are conferences worldwide. You can see several conferences going on, and in APMC conference was there in China, then International Wireless Communication. Then you have basically IMARC, which is scheduled for 2021 in Kanpur. Please prepare now and publish papers in that one. And you get an opportunity to come down to these conferences and interact with people. You will learn a lot. 10 times more you can learn by attending a class. That doesn't mean you should miss the class. You should also attend classes, also do this side by side. Then recently, they defined MTTS scope, and this is basically the spectrum. And we have RF device components and circuits. And as I said, you are in Hyderabad. It is basically father and mother of RF technology. So many companies, GATEC is there, foundries are there. And this is an area which is now identified as one of the best areas, RF systems application, wireless communication, 5G, 6G, radar sensing system, wireless power transfer, RFID, connecting autonomous systems, and then biological effects, medical application. And you can see Apple is coming up with a watch where you can measure glucose non-invasive. So 6G is driving towards millimeter wave research. So this is, whether you like it or no, you have to learn millimeter wave techniques so that we can develop our own 5G, 6G systems. Also look at healthcare applications. And we learned a lot from COVID. And you can see faster internet means we could survive in COVID. And I think in future, you don't know whether there will be COVID wave 2 or there will be some other pandemic. So we should be prepared and learn from the lessons we have from the experience which we had from last one. So we're all connected, like I'm teaching, is all because of very fast internet, which was not there a few years back. So we need to have advancement from megahertz to terahertz for humanity. Now, coming back, this is very important. I have not announced it. Hurry and join MTT-S soon, maybe tomorrow, because from India, I'm trying to generate some money, and we are now starting scholarships. 30 scholarships in the beginning will be announced soon. I will send it to all chapter chair first. This is basically for undergraduate, postgraduate, male and female, equally distributed, interested in doing a project with an identified mentor in RF microwave area. If you get selected, 30 is a large number, you get some fellowship of 10,000 rupees. All the selected students who will do work will be invited to attend IMARC 21 with free registration and travel grant to present this work which you will do in the project. Look for this, maybe within 15-20 days you will have this announcement. Apply, but most important things, you have to be an MTT member. Please hurry and join MTT-S and you will get these kind of benefits. So with these few words about the MTT, so we will also now go to a technical thing, which is basically development of some antennas for 5G applications. So let's go to part 2. Low-cost 5G antenna design and development. See, we don't bother about cost in India, and we talk of 5G, which is basically software. We don't look at how do we design antennas for our base stations and handset, and we don't bother about design and development. So I would like to go through this. This work is done all by students. How important is this area? So first of all, when you want to start a research or you want to do an undergraduate project, first find research gaps. A lot of research is coming out in the literature, and you need to find out what are the gaps so that actually we can very easily close these gaps. So we have excellent students at IIT Delhi. So I will share with you what is the recent work which we did. And this is a very hot topic, 5G, and tomorrow it is 6G. And this gives you a lot of opportunities to do publication because this is a very current area. And since you are going to have workshop on HFSS for 2 days, you will have a lot of hands-on experience. And for your information, which I have put at the end of this slide, all these designs which I'm going to present here are done by HFSS. So my sincere thanks to the entire HFSS team, and they have been helping us and we have been using it. We give them acknowledgement. And so when we could do it, you can also do it. And don't tell me that you don't have facility in Hyderabad. Hyderabad is 100 times better than Delhi in terms of the fabrication facility, in terms of resources and other things. So no excuses today. So look at it, we started many years back, 1G to 4G, and we have 1G, 2G, 3G, 4G. This is a very good article, 2013. So 1G, there was no official requirement. It was basically an analog technology deployed in 80s. And 2G was basically a digital technology. So first digital systems were deployed in 1990s. And we had CDMA, GSM. Then 3G was started basically. Primary technologies include CDMA 2000 and UMTS and WiMAX as official 3G technology. Though we say that in India we have 5G now, we don't have 5G. We still have 3G plus. And people say, I use Vodafone 4G. It's not 4G at all. 80% of the time signal doesn't come. But we are thankful to Jio. They really have an excellent Jio fiber network. You can see this presentation is done on the Jio Wi-Fi. So 4G, basically, we operated up to 40 megahertz radio channels with very high spectral efficiency. and IEEE 802.16 and LTE advanced. This is being designed to meet the requirement, which is basically long-term evolution is LTE is 3.5G. So millimeter wave mobile communication of 5G cellular, will it work? Answer is yes, it will work. So you have to look at it, how we started from 1G to 5G and what are they. So you have to find out what is the requirement first before you move. Then projected data consumption across the globe. This is the 5G of Samsung. If you look at by 2020, you have 50 billion users. Now we are already in 2021. It will touch down to 100 billion users beyond 2021. And the data rate, mobile data traffic, 24.3 exabytes in 2019. It is already crossed much higher. So why are we going to use the present networks? We cannot download a file on 3G and 4G, so we have to move to 5G. This is the Samsung's vision, which is projected. And continuing with the Samsung's 5 vision, these are user cases. We have basically healthcare services. As I said, mobile watch will check your ECG, check your blood sugar. We save power. We can use air conditioners which control remotely, IoT, smart city circuits, smart homes, media streaming, we can have cloud computing, we can have car services, then we have remote access services. So this is basically the smart city projects which Samsung is envisaging. If you want to do this high-speed thing, millions of people are connected, so we need a very high-speed system, low cost. So how do we go to 5G and 6G? So 4G is already built in. Many mobiles use it. The frequency, free space path loss, antenna and mobile terminal base stations. So 4G is 0.7 to 2.7, 87 dB is the loss in 200 meters. Electrically small and low gain antennas, phased array with beam can be used in the base station. But if you look at 25 gig, 5G, 28 gigahertz, 38 gigahertz, we have sub 6G also. Path loss is very high. So phased array concept is still not. It's questionable. People are looking at, we have a pattern diversity instead of phased array. Both are basically being developed for the 5G application. So this is what it is. And then since most of the phones are 4G compatible, so there is a thing, can we have 4G and millimeter wave 5G co-designed onto the, we don't need to do totally reinvention. Can we have the present phone, which is 4G, also compatible with 5G? So these are the broad thoughts which companies are looking at, because they don't want to invest billions of dollars to redesign everything. So if you look at the attenuation spectrum, this is the sea level versus frequency. There are a lot of attenuation peaks and a lot of valleys. And this is one of the valleys for the 5G application. Of course, this is a short range application. The world is divided on the choice of frequency for future 5G. In Asia, some people use sub 6G, Europe's 28, 30 gigahertz, and some people are thinking of 60 gigahertz. So main problem is low absorption, low path loss, and reasonable attenuation with rainfall. 28 gigahertz is advantageous, but people have to move to higher frequency because of the data rates. So there's a nice article in 2013, millimeter wave mobile for 5G, will it work? So 28 gigahertz has been identified, 38 gigahertz another, but in Japan they are looking at 60 gigahertz, but short range links, and 6G will be beyond this frequency. So we need to have antennas with high gain, we have to have diversity, we have to have phases, and most important thing is very low cost because it goes for commercial application. So in 2013, there was testing campaign in New York. So New York is very congested. So you use 24 dBi horns as transmitter and identical horn as receiver. So you could see that the distance where you could do transmission around 200 meters is what you can do. Otherwise, you have a lot of path loss, and then you have from a lot of signal coverage disruption because of the building. So typically about 200 meters in the outdoor range is what was found out by the researchers in this campaign. And then what are the challenges for 5G implementation? We have high path loss at 28 and beyond. Hardware designed at Ka band is challenging. Commercial radios of 4G and cellular design must be modified to accommodate 5G. We don't want to throw 4G. can we have 5G in it? So this is typical mobile handset, and can we have some antennas in this one, which will basically be 5G, and already we have 4G built in, so that we can have both 4G, 5G combined into the cellular phones, then the cost will be much lower. Now, requirement of a millimeter wave 5G mobile terminal is we want high gain, greater than 9 dBi, beam steering or pattern diversity, impedance bandwidth greater than 1 GHz, angular coverage at least 60 degrees, should fit inside commercial smartphones. Typical size is 150 by 60 by 6 millimeter. I don't want to do research where I make a 300 millimeter by 300 millimeter by 300 millimeter. Nobody will take it. Can we coexist this phone with 4G long-term evolutions, Wi-Fi, Bluetooth antennas? And then it has to be very easy to manufacture. It has to be extremely low cost. The antenna should be $1 or $2. Then only commercial companies will be interested. So this is very important to draw these things on a piece of paper before we actually start developing them. So Samsung did pioneering work on phased array around 28. So what was done is basically propagation loss between transmitter and receiver. So we have isotropic transmitter receiver 30 gigahertz theory, that is this one, very high loss. Isotropic transmitter receiver at 3 gigahertz, very low loss. And then we can use array at 30 gigahertz, so this is very low loss. So a patch antenna at 3 gigahertz is 60 millimeter by 60 millimeter. We can make an antenna array at 60 millimeter by 60 millimeter. It will work at 30 gigahertz. So we can use a small phased array in the mobile, and we can have this work for the 5G application. The path loss issue could be overcome by using high gain antenna on both mobile and base station, but locking the beam is a very tough job. So there are people still looking at is millimeter wave beam forming an enabling solution, or there are some problems. So this paper describes what are the problems. So people are thinking, should I use phased array or should I use pattern diversity? So this is still debatable, but loss at 30 and 3 gigahertz is considerably different, at least a factor of 20 dB. Then the proposed layout, if you look at the older generation 2G, 3G, 4G, the distance between handset base station is typically 1 to 2 kilometers. Here it is shown 580 meters, but we can stretch it to, so we can design the cell towers so that we can have the signal, 15 watt power can be pumped out, and we can have 1 watt from the mobile terminal. But when you go to high frequency, let's say 28 gigahertz, as I said, 200 meters is the range. If there are no buildings, it will further come down. So we need cell tower architecture to be changed maximum to 200 millimeter by placing base stations at 2 millimeter with similar link budget. So this is very, very important when we move from 1 gigahertz to 28 gigahertz. Then we have space constraints in mobile phone. If you look at mobile phone, lot of it, half of it is practically the battery. And if you look at Samsung, iPhone, Huawei, Google, the size is very, very small, and display size is 5.8 inches, and the weight is this. So we have to try to accommodate the 5G antennas into this phone so that we get the functionality. At the same time, you don't have to redesign everything into the phone. So this is typical 4G current phone. And can we introduce an antenna on the periphery in the same phone, which will be basically a millimeter wave, and then have the control signal for this so that it becomes a 5G phone? So this is some of the papers which is as old as 2017, millimeter wave 5G antennas for smartphone. A lot of research has been done in this area. Nobody knows which is the correct one. We have already a Bluetooth here, GPS, LTE. So we have to find out some space into the mobile where we can do this for future 5G applications. So our students found there are several research gaps in 5G designs. Most of the designs which are reported are planar in nature, hence creating a large footprint. I cannot fix it in mobile. I can publish a paper, but I cannot fix it in a mobile. So this is the footprint of a planar thing. So what we thought that, can we do a corner bend? I bend this antenna, and this will save me a lot of space. Second thing, which is very important, if I take a planar antenna, so from a planar antenna, we can have radiation. So we can have radiation from planar antenna, and this will be quite a bit will be towards you. But if we use a corner bend antenna, I can direct it towards the base station. So this will help you in radiating the signal away from you, and you can have less SSR basically by using corner band. So this was the thing with which our students started. Can we do a corner band antenna? So we went ahead with it. So we designed a conformal wideband slot antenna for 5G application. It's published in 2019 in the IEEE Access. So what we do, we use a coplanar waveguide here, and this is slot here. And this, you can use HFSS to optimize this, and you can go through this paper in detail. So this is a very nice antenna which works. Footprint is 20 millimeter by 16 millimeter, but it's too big to be attached to a mobile. And we can see the broadside gain typically about 2 dBi and input reflection coefficient around 25, 26 gigahertz, even 28 gigahertz is better than 10 dB. We can change the dimensions to accommodate the frequency to 28 gigahertz. So these were initial studies, but gain is still low. These are the patterns at 28 gigahertz. They're reasonably good. And then what we did, let's look at the corner band antenna. Can we bend this antenna? Yes, it was bent. And then using southwest connector, we can connect this thing and we can have a nice corner band. Now the footprint becomes very small, 9.5 millimeter by 6 millimeter. I can fit it in the periphery of the mobile. Now the gain improves. Forward gain becomes 4 dBi, and the return loss now is around 28 gigahertz, is about 10 dB. Now going ahead, patterns are good, and this is E-plane, H-plane patterns. Then the second problem was, can we increase the gain? So we use some frequency selective surfaces, analyze these frequency selective surfaces, S11, S22, and the phase, and wanted to incorporate it along with the other structures. So we developed a reflector consists of these frequency selective surfaces, and then mounted it so it acts as a reflector. Whatever signals come from here, and then we can. So you can see the radiation in this direction is minimum. It's only towards the base station we can have it. So this is the FFS structure which was integrated into this antenna. So this is how it is. Return loss of the antenna now is very broad return loss. Bandwidth is large, and then with offset, we can change the offset and see different characteristics. This is so once this is done, then we can find radiation patterns for these antennas, and the gain now improved to 7 dBi. It is very good, and gain also changes with the offset. So this study was also done. Now the next thing is, instead of having this one, can we have a 3D printed copper film, and we can have a contoured reflector to get much better characteristics. So this was done using 3D printed scaffolding, and we had an exponentially tapered reflector design. For this particular case, you can see the fabricated one. This is copper film now 3D printed, slot radiated, 3D printed scaffolding, 2.92 millimeter connector, and a copper film. And this is the pattern with and without the reflector. And then you can see the return loss of the antenna, and the grain of the proposed antenna goes to about 8 dBi. You can see systematically how the students use HFSS to get to different models of the antenna. Ultimate aim is that it should directly fit into the mobile. This is the patterns at 28, 30 gigahertz. These are the patterns at 28 and 30 gigahertz co and cross polarized things. Now, when you look at typical uses of the mobile phone, we can use it in portrait mode. We can use it landscape mode. When we have to do data or we have to call, we use either portrait mode, or when we have to send an email, we use landscape mode. So there is the problem of the phased array. We can have this antenna, we can combine multiple antenna, get the beam scanned in different directions. This is the concept of the phased array, but there are problems. What is the problem? 0 degrees, we get 12.6 dBi, 30 degrees, 7.5 dBi, 60 degrees, 7 dBi. So we need to compensate for this gain, and there's poor beam scanning as far as the phased array is concerned. So what we decided an orthogonal pattern diversity module to overcome this problem. And this is your radiating element, and this is your feed element. This is how the details of the radiating elements is. This is also very recently published by us. This is a coplanar feed, and this is the radiating element for the pattern diversity module. Then we can check the gain is about 5 dB, and return loss is very nice over the frequency of operation. Patterns are very nice. Then we use the FSS structure and analyze this separately so that we can have gain enhancement. So we use this as a reflector here, and then we do corner bend for this antenna the way we did earlier. So we have a nice antenna integrated with the reflector, and we can get almost 6-7 dB gain and a very good return loss over a broadband for this particular antenna. These are the H-plane patterns, these are the E-plane patterns for this particular antenna. This is 3D patterns without and with FSS at 28 gigahertz. It's very interesting results we are getting. Now, when you look at SAR reduction due to the reflector, you can see that in one case, it penetrates deep. In second case, it penetrates very less. And this is the proposed antenna. So we can have much better, because whenever we go to 5G, a lot of questions are asked. One of the persons who asks frequently question is our own close friend from IIT Bombay, Girish, that he always says it has health hazards. So whenever we have some designs proposed, we should propose a design where we take into account the specific absorption rate. This is very, very important. So this design gives you much lower SAR reduction. Then we can use one antenna here at port 1, one antenna at port 2, and gives me pattern diversity with the conformal antenna. So I can have the patterns for both the cases. So it eliminates the need for phased array. So we design, the second design is very low cost polycarbonate based antenna. So we use a pattern inset feed on polycarbonate substrate, and this is also published very recently. So this is how the antenna looks like. It's less than $1 in manufacturing. Then we can design another one, which is basically a tapered slot antenna, and this is fed by microstrip. This is a quarter wave transformer, again designed on HFSS. This is how the fabricated antenna looks. And then we have both of them overlapped. This is your slot antenna, and this is your tapered antenna, and this becomes a pattern diversity module. And the coupling is better than 30 dB between the two antennas, which is very good for practical applications. So this is E-plane in the portrait mode. You can see this is the pattern. In the landscape mode, this is the pattern. So basically, these diversity modules work very well for a practical application. Then the next thing is to test it. So we did a 3D molding of a mobile phone, and this is a smartphone. And then we mounted these antennas on the mountain, on the top, which is basically the roof, and did the testing. And we wanted to check whether the portrait mode and landscape mode signals are detectable. So you can see the portrait mode received power, and also landscape mode received power. And this is a realistic scenario, so we can actually get both portrait mode and landscape mode. The signals will be available, which basically proves that this concept of pattern diversity will actually work in a practical scenario. So going ahead, we did several other types of antenna. This is vertically mounted end fire antenna. And so we have basically this portion for landscape mode, this portion for portrait mode, and these are various radiators. And this is also done in 2020, very recent. This work is very, very recent. So if you look at antenna 1 here, and then this is 3D printed mobile piece, 3D printed, and this is the second antenna. So these are how the antennas will be fitted on a practical mobile. So this is port 1, port 2 patterns, which takes care of the diversity. And the next antenna we did is a shear ground plane bent antenna. So we have taken this antenna, which we showed earlier. This is also very recent paper which we have published, and using the corner bent antenna. This is one of the antennas, conformal inset fed patch antenna, which basically has been developed by the students. And then we use the earlier tapered slot antenna here. So this is the second antenna. And then we have basically a tapered slot antenna here, a tapered slot antenna here, then port 1, which is basically a microstrip patch antenna. This is how an antenna module will look like, which will go into the mobile antenna. There are 2 tapered slot antennas and 1 microstrip patch antenna to take care of the pattern diversity. So we can see the beam here, beam here, beam here to take care of all the 3 directions. And we have mutual coupling 40 dB between these 3 antennas. And we also did a lot of work on 4G, 5G co-located antennas. Can we design an antenna which will work at 4G as well as 5G? And then modified antenna, which is a corner band antenna, was developed. So we have basically an antenna for 5G, we have an antenna for 4G. It's a very, very compact antenna which can do a co-design of 4G, 5G antenna. So if you look at 4G characteristics, basically in this particular band, it radiates, reflection coefficient is very good, and these are the patterns for the antenna. And then we can do 4G MIMO by using 2 antennas. So this can also be integrated onto the same mobile. Then we can do a 5G antenna, and as I showed you earlier, we can use basically a corner bent antenna, which is a microstrip patch antenna. So we can use at port 1 one antenna, at port 2 another antenna for the diversity, whether it is portrait mode and it is landscape mode. So basically we can have now a very sophisticated antenna, which is 5G pattern diversity. We can have 4G pattern, 4G antennas, and we can have 4G LTE, 4G MIMO, millimeter wave 5G. So this is a very, very small antenna which takes care of both 4G and 5G antenna, can be very easily fitted onto a mobile phone. So these are other types of 4G antennas which we have done in 2019. It's a very, very small 4G antenna. It's a slot antenna, and then 5G millimeter wave tapered slot antenna. And this is how the layout looks like for 5G antenna. This is how it looks like for 4G LG antenna. And these are the feed lines for both of them. And these are the input reflection coefficients for the 4G, and this is for the millimeter wave antenna. So that means we can make one antenna which basically works for 4G and 5G. So this is important because we don't want to throw the existing mobile. We can integrate this antenna so that both 4G and 5G functionality will be there in this particular mobile. So you can look at it. Now we did this corner band antenna module fitted in the mobile case, and this is corner band 4G, 5G module into the second corner. And this is how it will look like. This is one corner, another corner of the mobile. This is 130 millimeter. We kept the same dimension, 130 to 90. So this is typical mobile phone using the 3G, this thing. And this is your orthogonal pattern diversity from these two antennas. This is an integration into an actual smartphone mock-up. And then we did the case study in the indoor environment. We put these antennas and we did the same way, the way I showed you earlier. And we can pick up both 4G receive powers as well as 5G receive powers in an actual scenario. And this proves that we can develop very, very sophisticated antennas, basically 4G, 5G. This is some of the recent work which we have done. And there's a lot of literature we have written. January 2021, which is last month, we wrote 3 articles on these compact antennas. Article 1 on compact antennas for future 5G smartphones. Part 2 is compact antenna future 5G smartphones and compact antenna future 5G pattern diversity architecture. And this is a free downloadable from Microwave Journal website. Please go to the website. These 3 articles will give you insight what is latest technology about the future 5G thing. And I and one of my students compiled the work which we did, many other designs. Since we have lack of time, we can't cover those designs. So the first book on millimeter wave antennas for 5G applications, which is basically for mobile as well as base stations. I didn't cover the base station antennas, I covered only 5G. This has come out in basically November, December from the CRC. So these are available online basically as an ebook. So read these articles, you will get fairly good idea. And as I said, we used HFSS to design most of these antennas. Since you have a workshop today, make best use of this workshop to learn. This is all done by our students. So you're also students, so you can also do exactly the same thing. And there are other interesting talks by the speakers, which is next to me, and also tomorrow Sandeep is there. And I think you will get a lot from this workshop. And it is possible only because of the support received from MTTS, and you can attend these workshops if you actually join as MTTS. I could present you some of the benefits of MTTs, but there are many, many more. So within a couple of months' time, when things become okay, we'll have a physical interaction with you at Hyderabad, and I will tell you more things. Only thing is you have to trust, to have patience. And as I said, all these are done by students. You can also, you're a student, you can do any of these yourself. It's a question of passion. It's a question of, yes, I want to do hardware. I want to do something for the country. Only then things will work. So the summary is benefits of joining IEEE MTTS was briefly described. We gave requirements for 5G mobile terminals. We did low-cost polycarbonate substrates. And using this thing, you get a 100 rupee antenna for 5G designs, because polycarbonate is a very low-cost substrate. Conformal designs presented a 28 overlapped module to cater for design desired specifications presented, real world case study of sensing power in indoor environmental, actual tests were done, and there are many low cost designs were presented. And if you download this ebook, they are all there. And co-design of 4G 5G antennas presented. See, we have to understand companies have invested billions of dollars. They don't want to suddenly change everything. So you have to actually sync your thoughts with the thoughts of the company, and then it is possible to actually do a meaningful designs. And with this, I think we come to an end. So I acknowledge all my colleagues at IIT Delhi, my PhD students from CARE, Indian Institute of Technology, Delhi. And as I said, most of the designs were done by HFSS. In fact, all designs were done by HFSS. And I'm really grateful and thanks to the HFSS team. I don't know whether they are there listening to this talk, but Srinivas can give a special thanks to HFSS team for supporting IIT Delhi, for supporting your college. And we will have many more workshops in future where we will present you the actual hardware, and you will present, maybe at some point in time, we can do a antenna design workshop while we can show you how to fabricate it in your own lab and test it. And this is what we will do in future so that you get much more confidence. And grades are important, but I think more important it is to do something with hand. That's very important. And I'm really thankful to all of you, to the principal for asking me to give a talk today. I hope you got some feel of what MTT, why MTT is important, and some feel of the kind of research, very recent research. As I showed you, most of the papers are 2019, 2020, and the books are 2021. And if you have any questions, you can send it to me. This is my email. You want to come and work with us for some time, you can come on this thing. And please feel free to discuss with us. If you need these slides, I can send a copy to Srinivas who can distribute it. Just send an email to me. I will be glad to do that. If there's a quick question, I can take it, because I have a little bit eaten 10 minutes of the next speaker, who is a close friend of mine. So I'm extremely sorry for that, but I wanted to just give you a proper perspective of both MTT and how the latest research is being done in our institute. And I specifically picked up this topic because most of the designs were done on HFSS, and you have an HFSS workshop. Thank you very much. A quick question, please let me know. Any quick question?
Thank you very much,
Otherwise, we can
sir.
break.
Any queries,
And
please?
I must take this opportunity to thank Lakshmi Narayan, who will be the next speaker. And I'm extremely sorry that I took your 10 minutes extra. So is there any quick question?
Thank you very much, sir.
And if you need slides, send me a request email. I will send it to you. You can
Okay, sir.
distribute it.
Thank you very much, sir, for your valuable lecture and suggestions.
Okay. Okay. Should I stop then?
Any doubts are most welcome, students.
No, students are normally shy in asking questions. Don't worry. They can
Yes.
email to me. My email is there. Anything
Yes.
you want for your career, you want guidance, I'm there for you. I'm like a fatherly figure for you. Don't hesitate. Any guidance, you need any help, you want to come to IIT Delhi, all those things I can take care of. But just email me.
Right, sir. Thank you very much, sir, once again
Thank
for
you.
your
Great.
valuable lecture.
Thank
And
you.
we will follow your guidelines.
And
We
please
are
thank
in
HFSS team on my behalf.
Dr. M. Lakshmi Narayan garu next speaker, sir.
Thank you. Thank you very much. Thank you, sir. Thank you. I'll
Thank you
stop.
very much.
Let's not take a 5 minutes tea break, have a snacks, and come back now.
Ma, please don't.
Waste time. Take a snacks and come back immediately.
The other speaker is waiting there.
Take a samosa if you want to bring your fruity inside and take it. Next session will be start exactly 11:35 to 12:20. 12:20 ante.
Sir, good morning. Sandeep here. You have to unmute yourself, sir.
Welcome back, everyone. Now it gives me immense pleasure to introduce to you our next guest, Dr. M. Lakshmi Narayana. Dr. M. Lakshmi Narayana did BTech in Electronics and Communication Engineering (ECE) from JNTU, Hyderabad in 1978, MTech in Microwave and Radar Engineering from IIT Kharagpur in 1980. PhD from Queen's University of Belfast, United Kingdom on Commonwealth Fellowship during September 1888 and December 1991. Dr. Lakshmi Narayana joined Defense Electronics Research Laboratory DLRL DRDO Hyderabad as Scientist B in Jan 1981. Over 34 years in DRDO, he immensely contributed towards ingenious development of antennas and microwave components for various projects and shouldered the responsibility of execution of electronic warfare projects and programs. He was Project Director for Ingenious Development of Advanced Communication ESM Technologies, achieved some reduction of gap in self-reliance. Dr. Lakshmi Narayana was Program Director of Naval Engineers Electronic Warfare Program. With 34 years of R&D experience, Dr. Lakshmi Narayana superannuated from DRDO service in April 2015 as Scientist H, Outstanding Scientist and Associate Director DLRL. After retirement from government service, Dr. Lakshmi Narayana worked as professor in ECE and principal of Kshatriya College of Engineering, Armoor. He was adjunct professor in Bharat Institute of Engineering and Technology, BIET, from August 2018 till April 2020. From August 2017, he is working as Director R&D with Unistring Technology Solutions, Tech Solutions, Hyderabad. Dr. Lakshmi Narayana has more than 30 publications in national and international conferences and journals. He guided a number of MTech scholars for the projects. 2 scholars got PhD under his guidance. Dr. Lakshmi Narayana is a fellow of the Institution of Electronics and Telecommunication Engineers, IEEE, fellow of Institution of Engineers India, IEI, and a senior member of Institution of Electrical and Electronics Engineer, IEEE, USA. He served IEEE Hyderabad section as Secretary, Chairman of MTT-APEMC Joint Societies Chapter, Vice Chairman, Chairman and Chair Nomination Committee of IEEE Hyderabad section. Thank you. We welcome you, sir. We welcome you today to our workshop, sir.
Sir, your voice is not audible.
Sir, voice not coming, sir.
ఆఫ్ చేయండి సార్. Hello. Sir, your voice not audible. Sir, అక్కడ ఆన్ చేసి Hello.
Now, okay. Are you now coming? Right. Right. Thank you. Am I audible now? Okay. Are you able to see my screen? Srinivas Rao.
Okay, sir.
Are you able to see my screen? Somebody should answer, I say.
Sir, it is visible. You can, I think you can start.
Okay, right. Thank you. Good morning, everybody. I thank the management of Matrusri Education Society and Matrusri Engineering College for conducting this 2-day workshop on microwave antennas measurements and simulation studies using HFSS. To the management as well as Mr. Sandeep Chaturvedi, who I think Sandeep Chaturvedi is attending this, the chapter chair. I thank all the chapter organization members, particularly Dr. Nukala Srinivas Rao and Mr. Naresh and Principal Dr. D. Hanumantarao for organizing this particular workshop. I am going to talk after listening to Dr. S.K. Kaul. Well, this is a very fundamental one. His work is almost up to date, very, very latest one. Just 1 second. Now, he exclusively represents MTT chapter, but we represent a giant chapter: antenna propagation, microwave theory techniques, and electromagnetic compatibility society chapters. Now, I congratulate Dr. Nukala Srinivas Rao even for taking good key role in promoting the IEEE activities. Particularly, I think I should congratulate the students coming up with the AP. Mostly, I think students are going to be attending this. I have taken a topic on antennas for IoT applications, right? Now, my talk is just I will introduce about the antennas and characteristics, antenna types, and some examples. Then antenna for IoTs. IoT is a buzzword nowadays everywhere. Internet of Things. Is the networking of physical devices for collection and transfer of data. Now, okay, then why an antenna is required for IoT? IoT means, it is the interconnecting of devices, number of millions, billions, even I think somewhere 50 billion mark is going to be touched in another, I think by 2024 or 25, something like that. Now, when number of devices are involved, their interconnecting is most important. Then how do you connect them? You connect it by wire or connecting without wire. Within a house, so many devices can be connected with wire. The remote, it is wireless. So there also we need an antenna, radiation. Yes. So antennas allow the users to get remote access to their device. For instance, nowadays, fans are also coming, remote controlled fans, refrigerators, as well as, air conditioners. These are all things which can be controlled remote. So there is a freedom. So these gives the freedom of location as well as movement. Right now, I am wearing, AirPods. If I wear the other things, earphones, I cannot move. But with AirPods, I can just move a couple of yards and come back and see here. So that means antenna is required for all remote access requirements. That means without using the wires. Then what are the wireless decisions? So this depends upon how much data we have to send. What range we need to send the data, how much range. Suppose if it is a TV, almost 10 to 20 feet, something like not more than 10 yards, something like that. What frequencies we can use and how much power is available. These are the certain 4 things I will deal with a little bit more detail. Now, data rate can be anywhere between 1 bit per second to even 1 gigabits per second. Just now, Dr. Kaul was talking about 5G. 5G where, the data goes on number of, now, just 1 second. Okay, goes on high data rates. Now, the data rate is a function of protocol, frequency, and power, right? Higher data rates require more power and higher bandwidth. Obviously, see, bits per second. More number of bits means requires more bandwidth. So, more bandwidth, just 1 second. Hello? I'm on a lecture, right? Okay, sorry. Now, the data, I thought that, if anybody, from the, MES or only if Nukala Srinivasarao calls, I will lift. Otherwise, all other phones, I don't lift. Thank you. Now, suppose range is there. Even it can be measured in long range, medium range, and short range. Short range can be as much as 10 centimeters. That is called near field communication. We call it as a near field communication. Suppose if you take it as a medium range, this all the medium range for a missile is different, medium long range for a missile is different. So whenever we use certain things, we define for our own requirement. So these are not a universal definitions. Suppose Wi-Fi maybe about 50 meters, 100 meters. But again, if you take even public Wi-Fi, it goes to couple of 100 meters also, like that. And for long range, it goes typically kilometers, particularly for cellular, because this is also required. Since that when we are talking about the data rate, I was also talking about the frequency. Now, the data rate is a function of the protocol, frequency, and power. That's what we told just now, right? Now, the higher the frequency means more bandwidth we can get it. Suppose if I got HF means at just 30 megahertz, all right, 1 to 30 megahertz. Normally we call 3 to 30 megahertz more academically. How much bandwidth we can normally we don't use more than a couple of kilohertz, right? Like that. 4 kilohertz is the maximum. Why something like that we use it. Suppose when we want 150 megahertz, 200 megahertz bandwidth, we need higher carrier, higher frequency. So that's where so different communications will use with different frequencies. Now, why should we use different frequencies? Suppose if I talk and you talk, there will be an interference. If I use the same frequency and other use the same frequency, there will be an interference. So in order to avoid the interference, we use different frequencies. Now, the power, higher data rates will require more power, right? And another this thing is, suppose if I shout loudly, means I am using more power to reach longer distances. Means lot more power is required to cover the long ranges. So these are the things which are required for the wireless requirement. Now, what are all the factors which are influence the antenna design? Slowly we'll come to the antenna design itself, right? So I am going to tell fundamentals of the antennas, but before that, just why to read that, that is the reason I am telling this, the requirement of antenna parameters. The moment we say that, what is the pattern shape, right? Pattern or shape of the designed antenna to match a specific frequency and bandwidth. What should be the size of the antenna, right? Shape of the antenna available. The space issues impact the antenna material shape. Just now, you all listened that, for a mobile antenna, the space is not just like that available. We have to design within the available shape, right? And then the material of the antenna also is going to decide the cost and its performance. For instance, FR4 material is almost 10 times cheaper than RT-derived materials, something like that. So these are all the things which we need to say. Then can I use the FR4 antenna for all the frequencies? No, I can't use beyond X band or beyond 6 gigahertz. The losses are very high. So that is the one thing. And the desired location of the antenna, it is to be dictated by the whether it is embedded, internal cabled. Now this is when in the case of IoT, we will be discussing, is it an embedded antenna or internal cabled antenna or something like a chip antenna, or a PCB antenna, something like that. We are going to discuss about this, right? In the coming to the location of an antenna, it can be embedded in the device, it can be external to the device, it can be an outdoor antenna, right? And this all depends upon the customer user condition. Suppose, a base station antenna is required. It has to be external only, outside only. Now, an antenna for mobile phone is required. It has to be embedded inside the antenna, inside the mobile phone. It is the embedded into the device, right? Like that it will be there, right? Now, again, if you say no specific antennas are needed for IoT devices. The typical antennas used for IoT devices are wire antenna, which are not new, whip antenna, which is not new again, rubber duck antenna, paddle antenna, chip antenna, PCB antenna. Okay, chip and PCB antennas are slightly new things to listen, but the way we have, these are also all derivatives of the existing antennas itself, right? We need dual band and multi-band antennas, right? And flexible antennas for certain applications, we require such things for body mounted devices or something like that. Even embedded antennas into the body, antennas can be embedded into the body. Most of the application functions are, it can particularly for these type of IoT devices, ISM band devices, licensed and unlicensed, the antennas also will be used. Medical body area networks is one of the wireless and avionics for intra-communication. Both these are all the dedicated spectra. This has to be a licensed one. Just like that, we can't use anything, right? Now, I have been talking about power, shape, pattern, frequency, and all those things. What is this for an antenna? So let us take some fundamentals. So just to be, more this thing for those who are the professionals may kindly excuse. This is for the students, those who are upcoming students. For them, this is a fundamental talk I am giving. The IEEE definition of the antenna is that part of transmitting or receiving system that is designed to radiate or receive the electromagnetic waves. That this everybody knows, but it is a formal definition. The antenna parameters are frequency, radiation pattern, gain, input impedance, bandwidth, and polarization. These are all, I will just explain these things which we have already just now. A lot of these words you have heard from Professor Dr. Kaul's, talk. Now, coming to the frequency, you can have any frequency, right, from kilohertz to terahertz. Now, of course, MTT-Society always goes from megahertz to terahertz, but even less than megahertz also we have to go to with other requirements, particularly EMC and electromagnetic compatibility, as well as the antenna propagation side of things. The most important thing is that radiation pattern is a graphical representation of the radiation properties of an antenna. What does it mean? Suppose I sit in the middle of the hall. Suppose you are sitting in the maybe in the conference hall, or Mathrusri engineering, that conference hall, whatever it is. Suppose even if you sit in this, student participants must be sitting right from the front row to the last row, right? A person sitting in the last row, right corner and left corner, and front row, first corner, left corner, center person, everybody should be able to get the signal. That means that is the area of coverage. But that area is coverage, everything is required. That means signal should reach the required areas. That is what is the radiation pattern. The radiation pattern, actually, we can see that this is a 3-dimensional. The way I am showing it here, it cannot be a 2-dimensional. It has to be a 3-dimensional. This particular one is shown for the very good understanding of a directional antenna, but it need not be. We will have a pakka omnidirectional antennas, something like that. We need everywhere. For instance, we need what you see. mobile antennas, more or less omnidirectional, more or less like that, right? So we get into the what is that? The moment you see an antenna will have one major lobe, rest are the minor lobes. Minor lobes are called the, you know, side lobes and back lobe. So these are undesired requirements for particularly for any requirement, particularly for the directional antennas for radar and electronic warfare applications. We will be very specific about mentioning these things. So the radiation pattern can be plotted as a polar plot or rectangular plot. We will have E plane or H plane. E plane and H plane, these two planes are called principal planes. Some people are also called E plane as azimuth and H plane as a elevation plane. It all depends upon the way you define according to your coordinate axis. It is your free to, there are certain definitions. IEEE recommended definitions are there. You can follow them. This is a 3D radiation pattern. Now, the most important one is that radiation pattern of a dipole we want. Normally, we'll be using the dipole, right? The dipole looks like pakka like a medu vada type of thing. You know, you see, this is whatever the circle, these like, you know, these are all the omnidirectional, we call it as actually round. See, we use one round circular, and in the elevation, this is, you know, elevation, it is somewhere different. So it has got a certain elevation coverage, and anything coming right on the head of the dipole, it cannot receive the signal, right? Whereas maximum signal is received perpendicular to the dipole, perpendicular to the axis of the dipole. Along the axis of the, along the dipole axis, you know, you won't get the signal. I mean, that is, there will not be any radiation in the Z direction. There will be maximum radiation in the Y direction, right? Any other things are normal, right? Okay. Now, the typical radiation patterns are, okay, the typical radiation patterns are omnidirectional, directional, fan beam, and shaped beam. Okay. See, so in the omnidirectional, this will be used for broadcasting and mobile telephony. For directional, we use for radar, microwave links. This is called pencil beam antennas. For fan beam antennas, we use for radar also. That is for search applications. And for satellite and radar, we use shaped beam antennas, right? But anyway, why I am telling you, may get surprised that I told that IoT applications, but antennas are antennas. Whether you use it for IoT or radar or communication or all these things, antenna general properties are going to be the same. That is a radiation pattern, right? For instance, a fan beam antenna, you know, an aircraft is intercepted here. An aircraft is detected here. Once it is detected here, you use a pencil beam for tracking, a small, you know, narrow beam for tracking, like that. Another important this thing is the directivity. How much is the directive gain of a receiving antenna? Now, suppose if directivity is a defined, I don't read this, this is known, everybody knows, and this is given in all the books. The concept of directivity is in a power or signal received in a particular direction, the power density in a particular direction. Suppose in this, let me say that, let us say that I am starting here, going to the in the Y direction. I use the antenna and get some power here, right? Get some power here. Let me say some power density. Then in this direction, but in this direction, I don't receive anything. And the directivity is the power ratio with this one, any input, plus if this is replaced by an omni antenna, omnidirection, an isotropic. See, isotropic antenna will give complete like a sphere of radiation. Whatever the sphere of radiation, that is, you know, 4 pi r square is the area, or 4 by 3 pi cube is the pi r cube is the volume. That much signal is reoriented in a particular direction. That particular direction, that ratio to the, when it is fully spherical type, that is called the directivity, right? So the gain is again directivity multiplied by its efficiency, means any power losses are there from the input to the radiating aperture. So that is the feeder loss, whatever is taking place, that we will take. Gain is the power delivered to the antenna. That means what is that? Antenna has got two parts. One is the radiating part, that is called antenna. The power will be given to the antenna by the antenna feed, right? So that is where the whatever at the input of the feed we will give, some loss will be there once it comes to the radiating part. So that is, if that is taken care of, that is we call as the gain of the antenna. Now, suppose for what shall I do? Do I all the time use these bigger equations? Should I solve all the time? So you know, phi theta phi p naught is equal to 0 to 2 pi, 0 to pi. All these things, shall I do all these things? This is required only during for the designer's part of it. For a user of the antenna, for a system manager of the antenna, say you are a signal processing person, you need, or you are a communication engineering person, but you need only an antenna. You don't know, you need not know, or you need not know the design part of the antenna. In such cases, see, you want to gain of some, let me say, when 10 dB gain you want. If you want to 10 dB gain, what you want? So certain beam width you require. So 30,000 by theta 1 multiplied by theta 2. Theta 1 and theta 2 are the 3 dB beam widths in degrees in the orthogonal principal planes of the antenna. Suppose theta 1, let me say 3 degrees, right? Theta 2 is equal to 1 degree. This will become how much? 10,000. 10,000 is equal to 40 dB. Otherwise, if I say 30 degrees, right? 30 degrees is theta 1 and 10 degrees is the theta 2, it will be only 100. 100 means 20 dB. Like that, you can just, you know, approximately, to the extent possible, approximately, you can, as a system managers, this is very requirement, and even an interview type of question also. If the azimuth and elevation plane beam widths, otherwise E-plane and HV plane beam widths are given, we can estimate the gain, right? Now, impedance. What part of impedance is again a very important factor, because whatever the power is given to the antenna, it has to radiate. So it will be having again radiation part and the reactance part. Antenna impedance is very important for the power transfer of power from transmitter to the antenna or from antenna to the receiver. So suppose if we say reflection coefficient, what does it mean? That's where you are looking at it. The moment, okay, impedance part without see, reflection coefficient means P reflected by P incident, right? Means whatever the power totally fed to the antenna will not be going 100%. Some part will be reflected depending upon its impedance properties. That's where we need to find, that's where we, in the laboratory, we measure that reflection coefficient, right? We using the slotted line, at least for the engineering college. These things can be done with a network analyzer later on in the higher stages. The bandwidth property. Now, for IoT antennas, hardly even kilohertz bandwidth is also required, megahertz bandwidth is also required. That means the bandwidth is to be defined. And another this thing is, everybody knows, or this is a fundamental property, that gain and bandwidth gain bandwidth product is constant. This is applicable to the antennas also. Suppose if it is a very tuned antenna, narrow bandwidth, gain will be higher. If it is a very wide bandwidth, gain will be lower. Now, narrow band antennas, broadband antennas, we call. Now, suppose if I say that a particular antenna has got only 1% bandwidth. Suppose everybody says that microstrip antennas has got the narrow band antennas. What does it mean? 1 or 2% bandwidth we call. Suppose if I design the antenna at, 2 gigahertz, right? 2 gigahertz, how much bandwidth will I get? 1%, if I get it, 1% means what? Only 20 megahertz, right? Like that. So in such cases, the definition is upper frequency minus lower frequency by center frequency. This is what the definition for narrowband antennas we say. For broadband antennas, upper and lower frequencies are good enough. We say that an antenna is called broadband antenna, or if it has got the, if it does not change its properties significantly over an octave or more. Octave means upper to lower is 2. That means frequency 2 to 4 is 1 octave. 4 to 8 is 1 octave. But 2 to 8 is 2 octaves. Something like that is called another, this particular. So the terminology changes from one application to the other application, right? Antenna polarization. I think this was also Professor Ka was mentioning. Now, antenna polarization, suppose if you take a mobile phone, mobile phone, if you want to keep like this and say that, okay, I should receive it. When you lie down, you will keep the antenna phone, mobile phone like this. So irrespective of the orientation of the mobile phone, we intend to receive. That means the polarization is the orientation of electric field of the wave. This can be vertical, this can be horizontal, this can be circular also. So in the case of that means the polarization is the orientation, the E vector rotation. As the time passes, right? As the time passes, now the polarization is of linear polarization broadly and circular polarization. The linear polarization is vertical, horizontal, or slant polarization. So vertical means vertical with respect to what? Vertical with respect to some reference ground. This is a vertical. With reference to the ground, it is a horizontal polarization. Now this is a vertical. We see the the E vector keeps rotating as it moves in the time. So normally there is nothing like circular polarization. It is an elliptic polarization generally. So it will be right hand circular or left hand circular. So the ratio of axial ratio is the ratio of the vector with major axis to the minor axis is called the axial ratio of the polarization capacity. Now looking at this thing, certain antennas we will see about this. A dipole antenna, a monopole antenna, and a ground plane. These are the very important concepts, right? A dipole antenna is a center-fed antenna like this. The feed need not be like this. Here it is. Here I have shown with a fed by a coaxial cable. Means center conductor of the coaxial cable is connected to one arm of the dipole, and outer conductor is connected to the other arm of the dipole. This is going to actually unbalanced. It requires a balanced feed. We do something for the purpose of understanding. We say we use a balloon, we convert it something like this. The length of the antenna is half wave. If we do this type of thing, we get the gain of 2.15 dB, and its beam width we call it is the elevation beam width is 78 degrees. Azimuth beam width is 360 degrees. It covers a total 360 degrees in the azimuth. Right? This is the dipole properties. If it looks like this. Of course, this is only cut for the understanding. It looks like if it is a half wave dipole, this is the one. If it looks like the radiation resistance is 73 ohms approximately, right? And it is, suppose if I increase it length to one wavelength lambda, what will happen? The impedance at the feed, instead of showing 73 ohms, it will show 2000 ohms, right? And the vertical beam width will be reducing from 78 to 47 like this. So what is happen if I increase further? What will happen? Actually, this may be 200 ohms only, not 2000 ohms. It is a print mistake could be. And 3.5 lambda means it will show up a number of lobes. Sorry, something is going on in the upper floor, right? Right. Now, a ground plane will produce an image current having a phase shift of 180 degrees with respect to the original one. A ground plane, suppose if I take the ground plane with horizontal this thing, it will produce a phase shift of 180 degrees. It will produce like this, and resultant is going to be 0. That is the reason this is one of the boundary condition on a metal. Ground plane is a conducting material. So this is one of the first boundary. Another boundary condition is any electric field perpendicular to the conductor is continuous, means it will produce another image which is going to enhance. This is where we are. Once when we learn electromagnetic theory, we talk about the boundary conditions. Same boundary conditions once we apply here, we say the properties of the ground plane. Right? Now, suppose I need not take, I will take just, just now using this property, I will take, right? A ground plane, I will take it. This will become a monopole. Instead of using two, I will use a conducting plate and a connect input to the antenna here. Instead of using lambda by 2, instead of using a half wavelength, I can use half of that one. I can use only quarter wavelength, right? The mirroring principle creates image of the monopole transforming into a actually dipole property only, but physical size is only the one which I shown. Here, the moment I say the ground plane is a conducting, the property of the radiation property depends on the property of the ground plane. If it is a perfect ground plane, the pattern looks like the one I have shown here, the top one, A. If it is a lossy ground plane, something like an earth or something, where this thing is there, this pattern will be like this. This is a lossy ground plane. Even, right, this is, suppose sometimes we may have to put a, conducting layers for the particularly at low frequency at HF, right? This is the most important antenna for IoT applications, right? Whether it is IoT or anything, most of the applications are dipole monopoles, loop antennas, slot, horn antennas, microstrip antennas, log periodic antennas, reflector antennas, dielectric lens antennas, and helical antennas. Of course, frequency independent antennas normally we don't use for the IoT applications. Now, looking at, okay, apart from IoT, people have not even, most of the antennas are classified based on the application. Here, IoT antennas comes under, I do not know whether people do not put any these things so far, radar antennas, communication antennas, telemetry, EW antennas, right? Let us take that as of now, Internet of Things is it communicates with one device to the other device. Let us take into the category of communication antennas, right? Based on bandwidth properties, resonant antennas, right? Broadband antennas, frequency independent antennas, most of the IoT antennas are resonant antennas. Here and there, even broadband antennas are very rare. Pattern coverage wise, IoT antennas are omnidirectional antennas, mostly omnidirectional antennas, and some directional antennas for the cellular when we utilize from base station to base station. Such things are different, right? Based on construction, wire antennas, aperture antennas, lens antennas, printed antennas. Wire antennas are IoT antennas, printed antennas are there, chip antennas are going to be there, little bit we call rubber duck antennas, we are going to be already told me, these are based on the construction also, but this is the general classification. Now, coming to the IoT applications, how to use, how to select an antenna. So that means we need to look at the wireless protocols. Am I using for a Wi-Fi or Bluetooth or Zigbee or Z-Wave, LoRa, Sigfox or cellular? It depends upon, this is the where the data rate is shown into the y-axis and the range is shown in the x-axis, right? If you show these things, Wi-Fi will be the highest data rate will be using. Now, see, the N is the near field communication, order of centimeters only, right? Then coming to most of the protocols will be in the meters range only, means 50 meters, 100 meters, something like that. And this is the cellular and other Sigfox are bit kilometers range. It will be having, right? This is also the same thing. Now, again, we were talking, then when we choose an antenna, we also need to choose depending upon the power. Now, power usage, in the beginning, the first slide itself, I told how much power is required. It depends upon the data rate. It depends upon the range, right? But depending upon the range, as well as, if you see the protocols, what are 10 nanowatts to right? 100 watts we will be using. Means desktop, laptop, GSM around 1 watt, palm top, something like this. Hearing aids, RFID, electronic watch, we will be using 1 microwatt. That means depending upon the power usage, we have to select the antenna, right? Some button batteries, AAWC batteries, these are all power requirements, right? Just now I showed the wireless protocols. The other one I just showed here did not show that I showed the data rate as well as the, the range. But here, if you see, look at the frequencies. Most of the frequencies are same for Zigbee, Bluetooth, and Wi-Fi. Let us step up. Wi-Fi more than 2.4 gigahertz is also there, but have the different ranges. Range is up to Zigbee 100, and Wi-Fi is just 50 meters. Okay, more or less, range is also normally, not very different for both. But if you see the data rate is ranging from 250 kilobits per second to up to 1 gigabits per second. Here, the Zigbee type of things are home alarm, door open. For these type of things, you don't need lot of data rate. Whereas for Bluetooth, 1 Mbps, music transfer, audio, just now, I am using the Bluetooth like, AirPods, something like. If you go to, Wi-Fi, video, movie transfer, that means those frequency is same. The data rate is going to be different, range going to be different. Depending on these things, you have to choose an antenna, right? Okay, factors influencing I have already shown. Some antennas are called embedded antennas. These antennas are kept customers' device and mounted on the PCB, right? And internal cabled antennas. They are going to be inside customer's device and coaxial cable connected to the PCB. Something I will explain these things in a little bit more detail here later. If you see that Zigbee, I told 2.4, but it is also at 915 megahertz. Also, it is there, right? Z-Wave 2.4, Bluetooth 2.4, Wi-Fi can be 2.4, 3.6, 4.9, 5 gigahertz, even 5.9 gigahertz. Also, people are taking, right? GPS is already there in the 1575 megahertz, 1227 megahertz, and 1176 megahertz. Like this, IoT is an industrial IoT. They also use the 2.4 gigahertz, LPWAN, medical, avionics, like this. If you see, all these things start from the minimum frequency is going to be 433 megahertz, where LoRa is using in Asia, right, to about 4,400 megahertz or 5.9 gigahertz. 5.9 gigahertz is highest. So near about some 430 megahertz to see all ISM bands will become 430 megahertz, 915, 2.4, 5.9. These are the 4 popular frequencies which we will be dealing with IoT antennas. Right. Now, VIP antenna and the ground plane considerations. VIP antenna is called it looks like a Telugulo betta untam VIP laga undi kabatti this is the VIP antenna, right? Just 1 second. VIP, rubber duck, paddle antennas are the most commonly used. These are the monopole antennas. They are not integrated onto the PCB of the IoT device and can therefore be more convenient for prototyping, right? The coaxial cable shields are now when it comes to the moment I am telling monopole, just now I told monopole requires a ground plane. If this type of antenna is there, where will you use the ground plane? The ground plane is the moment you are going to connect the input here to a coaxial cable is the outer cable is the ground plane, right? That it uses as the ground plane. Coaxial cables to shield serves as the ground plane to coax fed monopoles like VIP antennas, right? VIP antennas can also be designed to be ingress protected. Means, suppose this antenna, if I have to mount it outside, So there is called, this is the ingress protection. We call it as IP67 and IP68. These save the antenna from the outdoor harsh environments, right? The industrial environments where water, dirt, oil, and other chemicals may damage an antenna. Even something you must be seeing that, Wi-Fi antennas will be in the corridors, it will be hanging, something like that, right? Now, I just taking, this type of antenna, if you see, he says quarter wave monopole at 433 megahertz. 433 megahertz means just you, for the understanding, take 500 megahertz. 500 megahertz, the wavelength is how much? 500 megahertz wavelength is 60 centimeters. 60 centimeters lambda by 4 will become 30 centimeters. Now, this fellow is giving within, 20 centimeters, because some construction, this thing is also required for the purpose of, shaping and other things. 50 ohm impedance, right? This operates, this has got some, 22 grams only. And its temperature range minus 42 plus 70 degrees. This is where it works, like this. And looking at this thing, suppose I have got again, 433 megahertz, I showed you 20 centimeters antenna. Here another antenna is also there. Here, what is just a gain of 2 dB I gain. Here I am giving 1.5 dB gain. Here, the length of the antenna is just 50 mm, just 5 centimeters. Just 5 centimeters only, right? The polarization, everything is there, and this can even take 50 watts of power. These particular things are directly connected to the PCB, directly connected. So this can be utilized for the LoRa protocol, right? Something like this. That means an antenna has to be that lambda by 4 principle is recommended, but we have to tailor it depending upon the, 50 mm and 20 centimeters. Means here, how are we getting the 1.5 dB gain? Here the bandwidth is very, very, very small in the almost resonant type. So that's the reason we are getting. This is called rubber antenna also. This is called the rubber antenna, 433 megahertz rubber antenna, right? This is a radiation pattern. Now, certain antenna, patch antennas are also can be used. So I'm not putting any microstrip antennas. Almost everybody knows. As patch antennas are often used for IoT devices with GPS capabilities, right? Most of the GPS antennas are almost 100% GPS antennas are either right-hand circularly polarized or left-hand circularly polarized, right? The patch antennas can be designed for the dual polarization, right? Which can be reconfigured to switching a perturbation element with pin diodes, or means I can use the same antenna. I don't have to use different antennas for circular and LHCP and RHCP. Same antenna I can switch between the LHCP and RHCP. This is what we have done. Actually, my scholar also got a PhD in reconfigurable antennas, right? Now, the another most important things which you must be, I don't know, even this is chip and PCB antenna consideration. There is a chip antenna. It is normally you must have heard about the chip resistor, chip capacitor, right? We rarely listen about the chip antenna. Yes, it is true. Chip antennas are also available. IoT devices with embedded antennas like chip and PCB have their benefits, fitting into smaller places, right? Now, these are the conductive traces, right? PCB antennas are often, on the PC itself, we will again print some conductors and tell it is an antenna. Yes, it under certain conditions it works, right? There are different antennas like, inverted F antenna, L antenna. Most of these all printed antennas are, we can say, PCB antennas also, because we will be printing on the PCB. Why we call it PCB antenna? Along with the antenna, if some circuitry is there, we call it PCB antenna. Otherwise, it is an antenna itself. Suppose if I print an RT-derived substrate, if I print a microstrip antenna, I call it still a microstrip antenna, not a PCB antenna. But we call it specifically PCB antenna is like this. I have got other things, but still I am having an antenna here, trace. Then I call it as a PCB antenna for Wi-Fi. I just come for that one, right? The ground plane is of particular importance. whether it is a PCB antenna or a chip antenna, ground plane considerations will take top priority. Smaller ground plane results in very narrow bandwidth, less radiation efficiency, and radiation patterns also changes, right? Omnidirectional chip antennas generally have a cardioid pattern. Suppose if you see that this is a chip antenna. Chip antenna is here. That's it, here. Right. This is the matching circuit, whatever you call. This is a matching circuit. This is a conductor, this thing, because it has to, input is coming from here, from tracks. So this much small antenna, see, if you see, this board itself is 39.5 mm, means some 4 centimeters, you can say. In this 6.5 mm is the area for the, this yellow one is the ground plane. And here, this is the chip antenna is even much more smaller, just 2 mm or 3 mm, something like this. This antenna has got a pattern like a cardioid pattern, whatever you call. Suppose when this particular thing is there, this particular fellow cannot be having nulls here. In order to avoid the nulls, we use two antennas. One is here, one is here. This is one antenna, another is other antenna. The red one is one antenna, blue one is other antenna. So wherever the nulls are there for one antenna, blue, see, for red null is here. There the blue will cover. Here, like this. Where the blue null is there, red antenna will cover. So this type of whole PCB, right? Chip antenna we can be on the PCB, but PCB antenna is and again a different antenna. This type of things we will have in an enclosure like this, so that it can be working along with the PCB outside. Right? This is the chip antenna example. I think the time is approaching. In another 2-3 minutes, I will conclude. The chip antennas are available in, see, for Wi-Fi 2.4 gigahertz, right? Bluetooth, WiMAX, right? GSM 380 megahertz to 1900 megahertz, CDMA, GPS. So these are all, for all these things, chip antennas are used. Suppose inside a mobile phone, small these things are required. Now the chip antennas are just like, it is not just a casual antennas. We have got IEEE standards for that. Chip antennas have to comply with the electronic standards of the IEEE. This is 802.11, and it is a widely accepted wireless network standard. Now, where are you using chip antennas? We will be using, see, so far for the last 1 hour, we spoke about the 5G, 4G and all those things. But there, instead of the full antenna, somewhere we will be using these also. Chip antennas are utilized across breadth of telecommunication products. This is the where I told IoT antennas comes under the communication antennas. This includes PC peripherals, cell phones, PDAs, right? And tablet computers, portable television, satellite radio, headsets, USB dongles, GPS and Wi-Fi, WLAN, means chip antennas are like as widely can be used as some chip registers which we use in the electronic circuitry, right? See, now this is a PCB trace antenna. In the PCB trace antenna, see, these chip antennas are also required. Wherever required, maybe some of them may be chip resistors, some of them may be this thing, but here our intention is, this is the RF source. When this RF source is connected to here, this is the antenna which will be radiating here for Wi-Fi, PCB trace antenna for Wi-Fi purposes. This is the feeder line, right? Another PCB type of antennas are CC with antenna, see, internal PCB antenna for 2G, 3G, 4G applications. This is what Dr. Kaur was talking. If I am having, I can't throw out my device just like that. So we have to utilize them. So one antenna will be working for 2G, 3G and 4G applications. They are all coaxial fed, right? Another thing is, 2.4 gigahertz a transceiver module. This is again a antenna here, the gold color is shown. This is the antenna. This is a PCB antenna here. These antennas are, on the PCB they are mounted. So that is what these are connected to. Again, these become part of the whole PCB. So that's the reason they call it the PCB antennas, right? Now, okay, looking at the PCB antennas, kya badi baat hai? How it is going? Is it going to be different from antenna community? No. It is still the most, these things are all as a general antenna properties which I have discussed earlier in the antenna properties. That is PCB substrate dielectric properties, thickness of the PCB, length, width, like this, bending of RF traces, right? Dielectric properties, vias, component footprints, active components present on the, because you see there may be another so many other components. This antenna has to work in presence of them, or how this is there, how these have to be isolated when a lacquer coating is given, whether lacquer coating is given onto the circuit as well as the antenna, if the lacquer coating is given antenna, whether will it lose its properties, these are all to be seen for these things. The last one, I think this is the last but one, directional antennas are also used for IoT. Why do we use? For longer distance we cover, mostly Yagi type of antennas are used and sector type of antennas are used. Since these are very popular antennas, I am not going to touch much. See that Yagi antennas, the panel, see Yagi antennas are normally for used for SCADA, supervisory control and data acquisition, right? Systems for IIoT, industrial IoT. So though Yagi antenna is our old friend, the moment we say it is an IoT antenna, it is not going to be different from the antenna community. Some of the antennas are we are hand picking depending upon the application we are using for IoT. The same Yagi antenna we use for the TV, same Yagi antenna we use for some other applications. Like this, the depending upon the application we use the antennas. Suppose panel antennas, sector antennas are not new. They are not exclusively for IoT. These are also exhibit wider beam width, right? Wider beam width than Yagi antennas, right? Beam width is a requirement. When the longer distance is there, covering and gain, beam width, bandwidth, all these things are important. Particularly, I showed there in that, in the beginning, Sigfox, LoRa, these are require, some longer communication distances, longer ranges. So these are the required. And WLAN base stations, multiple structures can be mounted together to provide 360 degrees coverage. So suppose if one antenna covers me 120 degrees, I use 3 antennas to cover 360 degrees, like our mobile communication towers in the base stations, right? This is what it looks like, a Yagi antenna. This is the last slide. Now here a Yagi antenna, again see a reflector, and this is the folded dipole. Generally it is a dipole. So dipole will be radiating whatever the dipole radiation will have figure of 8. So this figure of 8 will be reflected by the reflector, and these are the directors. So the direct to beam will be here. It will be, so the back lobe will be reduced because of the reflector. Here the beam width and gain depends upon the number of directors. If I take just 2 element beam, it will be more wider beam. 3 element is slightly narrower. 5 element will be even narrower. We can go even up to 7 or 9 elements also, like this. That means, now to conclude, we have see that antennas are generally required for all applications. Particularly, most of the students will be talking about IoT applications, but nobody talks about the antenna. Simply they will take some chip board and other things. This particular one, 40 kilometers to 60 kilometers also will be, this covers. And the Yagi antennas covers 300 to 3000 megahertz, and VHF 30 to 300 megahertz. And all the chip antennas, most of the chip antennas are work up to 6 gigahertz. Mostly, normally we use up to for IoT applications, where the very small, but the gain is high, because maybe the bandwidth may be 1 or 2 kilohertz. So that is will be, as long as cost is less, application is better, and volume is smaller. Can we use a chip antenna for a radar? We can't use it. So depending upon these things, so we need, I think, this is, I thank you all for your kind attention, and I congratulate once again the Matrusri Engineering College, MTT Student Branch Chapter, as well as AP Student Branch Chapter, which is going to be approved, or by this time it must have approved. Thank you very much. I conclude here. Any doubts? You can please come.
Thank you very much, sir. One question is the basic difference between 4G and 5G in terms of temperature and resistance.
Okay, temperature normally you see if we use in the Rajasthan area, even the daytime temperature itself will go to 53, 54 degrees. Rajasthan area. When we went for the electronic warfare testing equipment, we saw we could not come out after at least by 9:30 a.m. It will be about to 48 degrees. So
Yes, sir.
temperature normally will be higher, but normally these things is taken care of in the device enclosure.
Yes, sir.
Even this 5G, once we take it out, we take this out. You see, and we don't keep it in the air conditioned, and we, you see, wherever we are, our mobile phone will be with us. So the
Yes.
entire device, this thing will be taken care of for the temperature design. Normally for minus 20, even for airborne applications, minus 40 to plus 75 degrees, we will be weatherizing these things. So I think this type of things, of course, the cost will increase. It all depends upon the number of volume production. And one more, this thing you are asking, temperature and
Resistance, resistivity.
okay, resistance or impedance, whatever it is, suppose see the input resistance is going to be, again, depends upon, let us take 50 ohms also. But if we suppose if I switch one PCB antenna, one pin diode, it will connect me to antenna 1. If another pin diode, antenna 2, but I don't switch it depending upon the requirement. Otherwise, I use simply a power divider type of things, or what is it called? Other microwave components are there, diplexer. There, the two frequencies will enter into the circuit at a time, so that will be impedance matched. That is a part of the design. When more
Yes,
than
sir.
one antenna is embedded into one, right?
Yes. Thank you very much, sir.
Thank
Any
you.
other question from student side? Please be interact. Yourself. Any other questions, queries? Most welcome. From this you ask.
Good afternoon, sir.
Introduce yourself first.
Yeah, please go ahead.
My question is, what is the current development in India on 5G and millimeter wave technologies?
Okay. Right now, the 5G, we are practically sub 6 gigahertz only. Practically. Sub 6 gigahertz means less than 6 gigahertz. Right? Just recently, if you follow the news line, I think not even 3 or 4 days ago, Government of India has taken a decision to have to invest
Voice is not coming. Okay.
Okay, thank you, sir.
Sir, we are concluding, sir.
Thank you very much, sir. That was very knowledgeable. With this, we conclude with our morning session. Next, we have a hands-on session after the lunch break. So, request everyone to take lunch break till 1:15 and gather
Hello?
at room number.
Yes, sir.
Srinivas Rao, am I audible?
Yes, sir.
Yes, sir, you are audible, sir.
Hello? Okay. Now, coming to the 5G, I think more than 1 lakh crore something, that's the different part of the policy decision. The policy decision is there to deploy the 5G services in India. But according to the global these things, whatever, respected Professor Kaul and other people are working, they are all limited to the laboratory only as on today. Right. They will be coming because everything goes will. One, the main issue here is how to utilize the existing equipment, because 3G, 4G, up to 4G, it is that, these are all 2G, 3G, 4G or almost one type of thing. 5G is totally different, altogether different. So that is the reason, particularly the millimeter wave, when it is implemented 29 gigahertz somewhere, that is going to be the challenging one. That is mostly it will be utilized for very, very, dense areas like New York or the other areas, or very, Charminar area, particularly if we see, or even high tech city also nowadays it has become a dense area. So such places where that small base stations are required, very, very small base, very small in the sense number of base stations are required. So my suggestion, my opinion is, for our 90% of our population, we don't need actually 5G, but technology wise, we need to, encourage 5G. Those 20% or 15% who are there, high data saver, but particularly those, streaming of the data, industrial requirements, they need definitely some gigabits per second data, right? So for them, we have to wait. And 5G is definitely is going to, lot of opportunities are there, 5G. But I just now, Professor Kaul also told, even my experience, 1.5 years ago, I was given 4G SIM for my smartphone. Till today in Tarnaka, I am meeting only 3G BSNL, right? So it is we need to actually demand for these type of things, and 5G is definitely is going to come because 6G is already initiated, and most of the countries are looking towards India because Indian market is good, bigger one. Out of 130 crore population, even if 1%, in 100 persons buy a 5G, you see still you see 1.3 crore sets or even 1 crore sets, such a huge market. So I'm positive that 5G will be definitely deployed, but particularly I think by the end of this 2021, at least a couple of deployment should happen, right? Okay. Next, any other questions?
Sir, thank you very much, sir. Now
Thank you.
53 students are attending, and outside also online 30 plus are attending.
Very good.
And now we are dispersing for lunch, and HFSS simulation will start at 1:30 to 4:30 p.m.
Good,
physically.
good, good. Congratulations and thank all the participants. Sometime I think I am missing because most so this is the first one I am talking to Matrusri on a webinar. Otherwise, I used to visit every activity, technical activity. I personally attended. Let
We
us
are
see in
invite,
future.
we are inviting you and Kaul Garu and Sharma Garu from IIT Tiruchi as well as IIT Tirupati for Terra Technology workshop planned at our place, sir, with the support of MTT and technical collaboration. We will be the host, sir. All 43 students are enthusiastic. Morning 9:30 onwards to hear you people. And now tomorrow also they are Sandeep Satav, Chaturvedi are physically coming, and they are ready to educate our volunteers, and we are transmitting through YouTube link.
Thank you. Okay. Thank you. Congratulations to everybody. Have a nice,
Thank you very much, sir.
HFSS,
Thank you.
nice HFSS background. Right. Thank you. I'm disconnecting.
1 minute. Anyway, so all the student volunteers from today onwards online లేదా From today onwards, any IEEE event, it is not similar to that of non-technical. It is a highly technical content and not necessary. And the experts who all are available under MTT across the world, you can interact. That arrangement also being made by Matrusri MTT-Society within short time. And we have been circulated to you people to volunteer under IEEE as an office bearer, and you people responded. Tomorrow, at the end of the concluding session, we will call you and we will collect inputs from you. You have to propagate. It is your society. It is not Srinivas Rao or Naresh and some XYZ faculty. It is the student branch event with the support of local MTT-Society chapter. And we just now received the information from headquarters, that is IEEE USA. Shiban K. Kaul garu morning addressed you people. They are coming physically and addressing you people in terms of terahertz technology, nothing but 5G beyond and 6G in terms of communication. So we all are the rollers with a single wired antenna, remember. So lot of facilities college is giving. Yeah, and in IIT Delhi also they want to sponsor you if you are really proven talent in terms of antenna design, not only related to latest trends in technology, related to ECE. So Dr. S.K. Kaul, already 2 people energized through him. The one is Abhay Joshi, got 1 lakh rupee scholarship for completing his diploma course in IIT Delhi during hot summer. If you qualify in the test, internship in antenna design and metamaterial, they are imparting training. You will be clubbed with Rajasthan people. It is not Matrusri Engineering College group like this. Heterogeneous group. You have to cope up with them. You have to stay. You have to design. Then that real feel is very good. Nagaraj sir has done that and he got some benefit. So if you qualify in that, all 45 days, the IIT Delhi will sponsor you. All logistics, including lodging, boarding and stipend will be given for you if you successfully completed 45 days and design an antenna and publish a paper. Then you will get a minimum 32,000 rupees as stipend. That means 1 month stay, how much you are getting back? 30,000. Per day 1,000 they are giving, apart from lodging and boarding. That will be published in international IEEE magazine also, along with your design. So these all are some inputs we want to share with you. And now there will be a group photo. All of you please join here. For that purpose I am. Please come. Office bearers of MTT, those who are, please come along with others here.
Yes, ma'am. After this session, up to 1:25, you have a lunch break. 1:30, you can assemble in our EC department N203. SSP lab.
SSP lab.
SSP lab. You are supposed to be attend there.
1:30.
By 4:30, we will conclude. Don't worry, up to 5 o'clock. Tomorrow, the session will be start exactly by 10 itself. Means you are supposed to report here 9:45. Because IEEE chair and past chair is coming. There is a 15 minutes inaugural program. After that, we have a theoretical session followed by hands-on session. Okay, please come forward for your group photo.
Please come for a group photo.
Fast.
We have to